All right, so 5-5. Shh. Remember, I'm sick. Ladies and gentlemen, you're not talking. I can't yell over you. 5-5 is the last section, chapter 5. You definitely want a highlighter. And you might want your yellow sheet out, just so that you don't have to zip back and forth. Flip this back and forth. A highlighter would be good. Okay, so, shh, mouths are closed, let's get serious. All right, so today I'm going to talk to you about your double angle formulas. And then on the back, we've got power reducing formulas and half angle formulas. Almost sounds like we're exercising. All right, but we're not, see, so that's always a plus.
This is true.
I just want to take a pill and get skinny.
Me too.
I know, if only. All right, now, you need to know these. Sorry, you do. Learn them. I'd start putting them on flashcards. Everything on that yellow sheet that I gave you that pertains to this chapter. So, yeah. So I would put them on flashcards. And you got to just study them between now and Friday. I'm so sorry. Yes.
Is that all again, or is that separate?
Is it on there?
I don't know.
Okay, here's your yellow sheet. Well, there is a back to this. Your double angles are right here. See? Double angles right there. Are we ready? Shh. Okay. Now, we did skip, remember, the double angle section in 5-3. This is an easier way to do double angles, so you'll like it. We're going to replace, you only have one choice for sine of a double angle. You're going to replace it with 2 times the sine of u cosine of u. You have 2 options for tangent of a double angle. You can either have this or this. Now, if I find the sine of the double angle and the cosine of the double angle, and then I have to find the tangent of the double angle, I'm going to use this one. So if I have to find this and this and this, I'm going to use this one last, because I've already found those. And you'll see me do one of those here in a minute. Well, you'll see. When we do it, you'll see. Because here's sine of a double angle, here's cosine of a double angle, right? Doesn't this one for tangent involve both of those? So if I found this and this, can't I just put it in here? And you'll see that they're fractions. They're just fractions, rather than use this one. This one looks more complicated. I'll use it sometimes, it just depends. And then for cosine, you actually have 3 options. Cosine of a double angle, one of your options kind of looks like your sine cosine Pythagorean identity, right? That one looks very similar to, I don't know what. And this one, so these 2 are similar, but one has cosine, one has sine. You'll use them in different situations. It's a choice. So let's go through some of these problems and see, when do I use what. So, and you have to pay attention to your directions to see what they're asking you to do. So my voice is not holding out. This is the only lesson I've taught today. Gee. All right, you are to find all the solutions of 2 cosine of x plus sine of double angle x equals 0. So we're only going to replace the double angle. So I'm replacing the sine of 2x. We only have one choice with which to replace it with, correct? So I've got 2 cosine of x, that didn't change, plus sine of your double angle is 2 sine of x cosine of x. And try to keep the same. If this says 2x, then these are x's. If this says 2 theta, then these are thetas. You want to keep them the same. Equals 0. What do you propose I could do from here? Very good. They have a cosine in common. Do they have anything else in common? 2. And a 2. So I'm going to factor out a 2 cosine of x out in front of parentheses, still keeping the equal 0. So if I take this and divide it by itself, what do you get? This divided by this is what? 1. If I take away a cosine and a 2, cosine and 2, aren't you left with a sine of x? So plus sine of x. Now what do I do with this? Yes, you do. So you're going to set the 2 cosine of x equal to 0, split these apart, and then 1 plus sine of x equal to 0. So this isn't a whole lot different than what we've done before. We're just substituting more things. Michael? Didn't we just replace with what we have above? 2, the sine of a double angle is equal to this.
But like that, I don't get like how that.
Aren't these the same? One's got a u and one's got an x. It doesn't matter.
You know, what I'm saying is I understand like that substituting it in.
That's where I got, but you asked me where I got it from. That's where I got it from.
Well, this actually says.
They gave this equation here. Do you really want me to show you how it was derived? I don't think you really want to know. If I show you how it's derived, then I'll have to kill you. We don't want that. No. If you really want to know how it's derived, we could do that, but I don't think you're ready for it.
I was just wondering if that equation.
It's just like, you know, where do they come up with Pythagoras' theorem? Where do they come up with the distance formula? There's,
Well, I guess what I'm saying is like that, those equations can you've seen them, like I just.
Right.
Yeah.
right. That's for a higher level class. You don't want to go in. You don't want to go there right now. Just trust me.
You just threatened to murder someone.
I know, on videotape. But I love Michael. All right.
She's lying.
People from other than Horizon watch these tapes and watch, and I go, wow, she's strict. All right, so I want to get cosine of x by itself, so don't I divide by 2? And I get cosine of x is equal to 0. Don't we, I'm going to pull out from here, don't we need to look at what? Your unit circle. So cosine, remember, is equal to your x value. Cosine is equal to your x value in your ordered pair. So your ordered pairs here are, there goes my brain, 1, 0, 0, 1, 0, negative 1, and then negative 1, 0. We're at 0, pi over 2, pi, and 3 of pi over 2, right? So, which ones have an x value of 0? Right here, and right here. So, x is equal to pi over 2, and also 3 pi over 2. So, those answers come from this right here. Then we have to solve this one. Subtract 1, and we get sine of x is equal to negative 1. So looking at these same ordered pairs, and sine of x, yeah, sine is equal to y, wouldn't that be here, 3 pi over 2? Don't we already have it listed here? So I don't need to list it twice. So I only have 2 answers. Are you okay with that? It wasn't so bad, was it? Same thing, it's just using a different formula. Yep. Exactly. All right, so then let's look at this one. Now, this one is asking you to find, yes, this one's asking you to find sine of your double angle, cosine, and tangent of your double angles. You're finding all 3 of them. And they give you the cosine is equal to 5 over 13, and oh boy, it's restricted. What does that mean? Which quadrant is this? 4. So we are going to draw, first step, I'm going to draw our quadrant, and because of the restriction, we're going to put our reference triangle in the quadrant, in the 4th quadrant. And that we are using theta, so here's theta. Cosine is adjacent over hypotenuse. So adjacent is 5. My hypotenuse is 13. What's this one? Negative 12. How did you know that? To put that, well, first of all, this is the negative portion of the y-axis. This is a Pythagorean triple, right? Or what could you have used? Could have used Pythag theorem. Either way. All right, so now we have a full triangle. So now, step 2, we're ready to find our sine of double theta is equal to. So according to the formula above, isn't that equal to 2 sine of theta, cosine of theta?
Wait, is that sine squared theta? or-
No, it's sine of, it's a double angle, so it's sine of 2 times theta. So we're going to multiply it by 2/1 times, what's your sine of theta from this triangle here? Your sine of theta, if theta is your angle of reference, what's the sine? Negative 12 over 13. And then we have to find the cosine of theta, which you were already given, right? Which is times 5 over 13. There's nothing that I can cross cancel here, so you're just going to multiply it out. And 2 times 5 is 10, times negative 12, isn't that negative 120? What's 13 times 13? 169. That's it. That's your answer. I can't hear you, my ears are plugged. The only thing that divides into 169, because it's a perfect square, is 13 and 13, and that doesn't go into 120. If I could see anything crosswise up here, I would have tried to reduce it first. All right, so then step 3, if I were you, I would find the cosine of your double angle, not the tangent. That's last. So cosine of 2 theta is equal to, we have a choice. We can use any one of these 3 here. Which one did we just, well, we could use this one because they gave us cosine, right? We could use this one because we found sine. And we could still use this one. My preference would be, since they gave you cosine, that you use this one, because what if you made a mistake in finding that negative 12? Does that make sense? My choice would be to use this middle one. But you can choose any of those 3 that you want. You don't have to stick to that one. So we're going to write down here 2 cosine squared of theta minus 1, and write yourself a note that this is a choice. So let's go ahead and substitute 2/1 times, and then our cosine was 5/13, so I'm going to replace this right here with 5/13, but isn't it squared? And then minus 1. So all I have to do is do the math. 2/1 times 25 over 169 minus, what's my denominator here going to be? 169. I want to subtract 1. Shouldn't I convert 1 to something over 169? So 169 over 169. So then I end up with 2 times 25, which is 50, minus 169 over 169, because now they're both the same denominator. What do I get? Negative 119 over 169. That does not reduce. Now we have one more. 4. Tangent of double theta. I choose, out of my 2 choices, I choose this one, because I've already found the sine of my double angle and the cosine of my double angle. So all I have to do is put them in here and do the math. So again, it's a choice, but I would choose sine of double theta over cosine of double theta. And this one's easy to remember, because what is tangent? Normally, sine over cosine. So if I have my sine from up above is negative 120 over 169, that's my sine of my double angle, over my cosine of here, right here, is negative 119 over 169. How do you deal with a fraction in a fraction? Yeah. So we end up taking negative 120 over 169. So we take the, and we multiply by the reciprocal here. So we have 169 over negative 119. Don't your negatives cancel? Don't your 119 or 169s cancel? And aren't you left with 120 over 119? Are we okay with that? Do you see why I prefer to use that one and why I prefer to do it last? Danny,
Where you get through.
you get three, because they're asking for three different things above. It's all based upon what the directions are asking for. Yeah, if they had just asked me for sine of double theta or sine of, or I'm sorry, if they had asked me for the tangent of double theta only, I probably would have used the top one, the top equation, probably. Okay. All right, any questions before we flip to the back? All right, so flip to the back. Now we're going to look at our power reducing formulas. And look what the directions say. The directions quite clearly say write as a sum of the first powers, meaning we don't want anything to the second power. We want it raised to the first, an exponent of 1, so just sine, just cosine. And it says of the cosine of multiple angles, so it's going to be cosine of 2x. Cosine of 2x should be in our answer. That's okay to have. Now, having said that, you need to write yourself a note. It is understood that you will write your answer without a fraction or a trig function, sine, cosine, tangent, or any of the others, in the denominator. Okay. You should, okay. When I get down to the answer, I'll answer that question because I personally don't have an issue with having a number in the denominator, having your answer as a fraction, but just the number in the denominator. Okay.
It says without a fraction.
I know.
But then it says.
I know. Yeah, well, I'll show you. I'll show you. Just write it. Just write it and I'll explain.
No, you can have like a 2 in the denominator.
Yeah.
You can't have anything else.
But what he's saying is says don't write it as a fraction. And the only reason why I say that is because your book doesn't write it as a fraction. I personally have no issues with it written as a fraction. So I'll show you when we get to the answer, the two answers you might want to choose. But if you're trying to check your answer with the book answers, you're going to definitely want to do it without the fraction. So I'll show you what that looks like. All right. So having said that, we've got these three formulas. Again, they're all these formulas use cosine, don't they? Yeah. So they all use cosine. So we're going to replace sine squared and cosine squared with each of these. All right, so let's get to it. So we're going to take the 2, and I'm going to put the 2 as 2 over 1 because all of these are fractions. Then we are going to replace sine squared of x with 1 minus cosine of 2x because it's using x over 2. And I'm going to put the 1 minus cosine of 2x in parentheses. You'll see why in a moment. Then times, or I'm sorry, plus, we're going to replace the cosine squared right here with this fraction, 1 plus cosine of 2x over 2. I'm going to put the 1 plus cosine of 2x also in parentheses, and that's not really necessary. Are we okay with what I just did? Yeah.
I want you to do 2 over 1 for cosine.
You'll see why. Aren't I gonna have to multiply this together?
Yeah.
And I know that this cancels, don't do it yet. Because don't we have to add two fractions together? Don't we want them to have the same denominator? And if I cancel out that 2, right now this denominator is 2 and that denominator is 2 and that's what I want. So don't be so gung-ho to cancel that out yet. Be careful. So I end up with, I'm gonna go ahead and multiply the 2 through. So I'm gonna multiply the 2 through. 2, and then 2 times this is minus 2 cosine of x. And then this is plus 1, I'm going to squeeze it in here, plus cosine of 2x. All over the same denominator, right? Now in the numerator, can't I combine the 2 and the 1? So this equals 3, yes, question. I can't hear you.
It says cosine of 2x. We lost the 2x. 2x right here.
So the 2 cosine 2x.
See the
And
one,
the
so
blue.
here's,
And the blue. When you multiply it.
oh, did I moved I missed my 2 in there, thanks. Thank you. Alright, so I've got 2 plus 1 is 3. And then I've got a minus 2 cosine of 2x and a plus cosine of 2x. What does that give you? They're like terms, aren't they?
Negative cosine.
A negative cosine of 2x all over 2. I'm quite frankly perfectly happy with that answer. Okay, or you're not going to see that answer in your book, so that's why I want to show you or. What's your denominator? 2. Bless you. Dividing by 2 is the same as multiplying by what? Everybody? Dividing by 2 is the same as multiplying by 1/2. So whatever that number is there, if it's a 3, you're multiplying by 1/3. If it's a 10, you're multiplying by 1/10, right? So, or we're going to take this 2, and we're going to change it to 1/2 times the 3 minus cosine of 2x. Doesn't our answer have a multiple angle of cosine in it, 2x, and there's no fraction? And there's no trig function in the denominator. This is the answer you're going to see in your book. I don't have a huge issue right now with that answer, but you really need to get in the habit of putting it in this answer form. That one would be best. Am I going to mark you off if you give me this one? No, because I'm super happy that you're able to get there. This is a learning curve today. All right, any questions on that? So that was actually not too bad. The hard part here is knowing your formulas, isn't it? Yeah. Sorry. Only memorize the parts that relate to this chapter. And so it's chapter 4 and 5. Anything that we haven't done, like Heron's formula, on there, you don't need to know, right? So I would go through all of your formulas for chapters 4 and 5 and put them on flashcards. And if you go through your notes, you'll see where most of those formulas should be in your notes. So that should sift through it quite a bit. All right, so half angle formulas. Again, these look very similar. Again, they all have cosine in it with the exception of the tangent one. And again, on tangent, you have 2 different choices. They almost look like they're inverses of each other with the exception of what? Minus and a plus. Make sure you have the right sign in the right place because that would make a difference. All right, so here on this one, you're given the cosine of u is 3/5 and another restriction. What do you do with that? Well, this, and by the way, oh, let me point out, see how these are all plus minus, plus minus, plus minus? Oh, that one doesn't have it. But see how these are plus minuses? The sign, whether it's positive or negative, depends upon the quadrant in which the half angle lies. That's how you'll know whether your answer is a positive or negative for the sine and the cosine. So what quadrant are we I'm going to draw my coordinate grid. My reference triangle is going into quadrant 1. And they're using u for my angle name. So there's a u. And they give me cosine. What do I do with that? Cosine is whatever what? Adjacent over hypotenuse. So adjacent to u is 3. My hypotenuse is 5. What's going to be across over here? 4. You could get that knowing that it's the Pythagorean triple or your Pythagorean theorem. Either way. Now, all my signs are positive because we're in the first quadrant. So all of our answers to this particular example are all going to be positive. Right? All right, so we have to find all 3 of them. So we're going to start off with sine of the half angle. So we're going to use this formula. So sine of u over 2 is equal to, and I'm not even doing plus minus, I'm just doing the square root because I know I'm doing a positive, of 1 minus, what's the cosine of u? So that was given, right? It's 3/5. I'm going to put 3/5 in here for the cosine of u and divide it by 2. Won't this be a 5 over 5? Are you with me? What's 5 minus 3? So this is the square root of 2/5 over 2. 5 over 5. 5 minus 3 is 2, so it's 2 over 5. Can I skip that much with you? All right. And then this becomes the square root of 2/5. Instead of dividing, I'm multiplying. What's the reciprocal of 2? 1/2. The 2's cancel. And I get, what's the square root of 1? 1. And then I can't take the square root of 5. Can I leave my answer that way? No. So we're going to rationalize. Rationalize. And so the sine of my half angle is equal to radical 5 over 5. The 5's do not cancel because one's outside the radical, one's inside the radical. So you try cosine of your half angle. I'll be up here doing it with you. And again, I'm choosing a positive because I know I'm in quadrant 1. How'd you do with the cosine of your half angle? Any questions as to where I got my numbers? The tangent gets a smidgy hairy because there's 2 fractions in there. So be careful when you do your tangent. So you're going to do the tan of your half angle is equal to. Now, to me, it doesn't really matter which one you use. I would prefer to use the sine of u over 1 plus the cosine of u, only because you're doing addition. So that's why you'll see me using that one. You are going to have to find the sine, and the sine is opposite over hypotenuse. So we've got 4/5 over 1 plus, and then our cosine is 3/5. No square root. This becomes 5 over 5 plus 3/5 is 8/5. 4/5 times the reciprocal, 5/8. The 5's cancel. The 4 cancels and the 8 twice. And we end up with the tangent of our half angle being equal to 1/2. And again, remember, all of our answers are positive because we were restricted to the first quadrant. Otherwise, you'd figure out based upon what quadrant you're in. Andy?
Do we have to put a plus and minus in the outside?
No, because you have to decide what quadrant are we in, because we're restricted to the positive, or the quadrant 1. Sine, cosine, and tangent are positive in quadrant 1. If I were restricted to quadrant 2, then only sign would be positive in quadrant 2, so this one would have been positive, these two would have been negative. Well, let me put it this way. This one would have been negative. This one may or may not have been, but these signs would change. The sign would stay positive, but this one would have been negative down here. Does that make sense? The answer here could have been positive, depending upon what you ended up getting. But you have to pay attention to the quadrant.
Have you ever heard a song says